Hey everyone, welcome back to Code Meets World. Today I'm going to be tackling the 12th problem in the NeetCode 150. You might recall that last time I started the trees category, which turned out to go a bit better than I was expecting. I was thinking I would have a bit of trouble getting back into trees since it's been a while since I've done anything with them. But I was able to invert a binary tree. Check out the last video if you want to see how that went. And today I'm on to what's called maximum depth of a binary tree. Another easy problem. So let's jump right in. Okay, so here we appear to be given the root of a binary tree. So just like the last problem, we have another binary tree here. And binary tree is where there's just at most 2 children. So there could be 0, 1, or 2. So given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. Okay, so looking at this picture here, I would imagine that would be 3. The maximum depth would be 3. Because we would count 1, 2, 3. So we could also go 1, 2, 3. So basically, this problem is asking us, let's see, if we're given, this would just be a tree with 1 child, in which the output would be 2. And if the input was just the root, the answer would be 1. Because it has no children. So we're basically looking for how deep the tree is. So let me jump down to the whiteboard and talk through this. So this one is pretty self-explanatory. Let me write out this tree here. And I'm not even going to fill in the numbers because the numbers actually don't matter in this case. All we're interested in doing is looking at how many levels this tree has. And we add 1 for each level. So if there's a root, we automatically have a level of 1. If there's children, that adds a level. If any of those children have children, that adds a level. So a pretty simple problem to conceptualize, but how would we go about solving this? If we think back to the last problem, where we talked about 3 different ways you could traverse a tree: pre-order, in order, and post-order. Watch my last video linked above here if you need a refresher on the 3 different ways to traverse a tree. But knowing that those are our 3 options, we know that a pre-order traversal is going to count 1, 2, 3, 4, 5, like that. I don't really know if it matters which of these we use, actually, because we're pretty much looking to do a depth first traversal here. I did not talk about this in the last video. So in addition to these 3 tree traversal techniques, we also have depth and breadth searches. A depth first search goes as deep in the tree as it can and starts looking there. A breadth first search considers each row before it goes to the next. So what I mean by that is a depth first search would make its way down the tree as deeply as it can go, whereas a breadth first search would consider everything in the order of the rows, like that. So it would kind of make sense to do a depth first search here, which we can do, I think, I think we just do a post-order traversal to do that. Let me think about that for a second. So let me draw a fresh tree. So if we have a tree that looks like this, and we want to do a post-order traversal on it, that means we consider a node when we hit its right-hand side. So we would start here, we would come around, we hit this one's right-hand side, so we mark it. Then we come down here, we hit this one's right-hand side, this one's right-hand side, and then here, and then there. So this would get us down to the bottom of the tree as quickly as we can, which is good. And we pretty much just want to add one every time we go down to the children and keep track of that somewhere. Okay, so I think I'm going to try for a post-order traversal where each time that I move down a level, I add one, we'll have some sort of count like depth. We'll set it equal to 0 at the start, and then we'll add 1 to it each time we go down another level of the tree. Great. So let's flip back to the code, and we'll give this a try. All right. So just like last time, I think I might need a helper function to get this started. And what I did in the last video, because this is going to be a recursive solution as well, I think. So thinking about the simplest case, if the root is none, we would just want to return 0. Because if we're given an empty tree, it has no depth, so it is 0. And if that's not the case, we would say if root.left does not equal none, I used a similar strategy in the last one, so if in the last video, so if root.left does not equal none, meaning there are more children to go explore, we would want to return 1 plus, and then max depth, self, and root.left. So what I'm doing here is, say we're at this 3 here, and the root.left does not equal none. So what I want to do is return 1 plus, and then call this again on the left child. And so why am I adding 1 here? That's because I'm going to make each of these return a number each time it goes down another level, all the way until it gets to a none node, in which case it'll add 0 and return everything. So I think that's a little confusing, so I'll explain it again in a bit once we see if this works. So then if root.right does not equal none, we'll do the same thing. Return 1 plus max depth, self, and then root.right. Okay, and then once all of that happens, then we visit the node that we're at, because this is a post-order traversal, so that means we go to the left children and the right children before we do anything. So I'll say process current node, just to remind ourselves. And again, if we were doing an in-order traversal, this would happen in between them. And if we were doing a pre-order traversal, this would happen before both of them. I talked more about that in the last video as well. So to process the current node, oh, actually, I don't need to process the current node because I don't actually care what the values are. The numbers that are in these nodes do not matter at all. I don't have to do any swaps. I don't have to add anything. All I'm looking for is the depth of this tree. So I think, I don't think I need to do anything there. I think this might just work. Let me run it real quick. Max depth is not defined. Maybe I don't need this self here. Yeah, it might just be that. Max depth is still not defined. Okay, that is okay. So what I will do is what I did in the last video, which is depth. Max depth helper, which will take a root, and it will do all of this stuff. And then my main code will just call, or it'll just return max depth helper root, like that. Well, let's see if that's better. Oh, right, and then we gotta make these call the helper method. Unsupported operand types for plus int and none type. So say I put in, okay, hold on. So let's go to the test cases here. And let's put in, yeah. Let's just put in the tree that we see here. So it's saying I can't add int and none type. What if I try with just this one? Yeah, okay. So I have some sort of problem here. What I wanted to do is just add one each time. So maybe what I actually want to do is a better job of thinking about this recursively. So if you think of the simplest case, where I'm just looking at the root, I basically just want to return the maximum of everything I see to the left of me and everything I see to the right of me. So in this case, everything to the left of the root has a depth of 2, 1, 2, and everything to the right of the root, the max that we have is a depth of 3, 1, 2, 3. So in any case, in any situation, is a node. All I want to do is propagate up the maximum of the count I get from the left and the right sides of my path. So I think I can actually show that here. So I think I can actually say left total equals the max depth. Left total equals 1 plus this. And then I think I could say maybe right total equals 1 plus that. And then what I could do is return, so if the root is none, I return 0. So I'm adding stuff to this. So 1 plus 1 plus 1, and then eventually we get to here. And then here I could return the max of left total and right total, like that. What does that do for me? Referenced before assignment. So that's fine. I can just say left total equals 0, right total equals 0, and that way if I never see anything on either side, then that would be okay. Okay, so I gave the wrong answer. I outputted 1 when I should have outputted 2. Probably because I'm not accounting for the root properly. So this should fix that. Oh, I still gave an output of 1. when it's expected to be 2. Oh, it's probably actually supposed to be like this. Because I want to take the max of the 2 and then add myself. Which actually outputs 3. So return the max of the 2 plus 1. Or maybe I actually need to add that here. So that gets me corrected there, but what about this one? Okay, so that worked for both of them. Let's submit and see if that was correct. So I passed 38 out of 39 test cases, but I did not pass the one where the root is null. So that's an easy fix. I could just check it straight up and just say if root is none, return 0. Otherwise we return that. So this should be complete. Okay, so that one is finished. If anyone is struggling to follow along with what actually happened there at the end. So the reason my first one was wrong is because I wasn't quite thinking about the problem correctly. What I realized I needed to do was just count how deep the tree was on the left, count how deep the tree was on the right, and take the maximum of those 2 values. So the way we did that is setting a base case for our recursion that if we get to a none spot, we don't need to add any more levels. But if there's a left-hand node to visit, we add 1 to the depth and then iterate recursively over that left subtree, and we store whatever that total is. So say it's depth 8, we keep track of that. And say the right goes to depth 5 or something like that using the same technique. Then we take the max of left and right. So if it was 8 and 5, we would take 8. That's the deepest part of the tree. And then we would return that. And then we would add 1 for the root node. If the root is none, we just return 0 from the start. So yeah, hopefully that makes sense. I guess it was a fairly quick solution, so I'm happy about that. I didn't do very well with memory usage, probably because I'm adding up all of these totals. I think there was a better way I could have done this without having to store the value. Maybe I could have done the max just straight inside of here without keeping track of it. So there was definitely a better way to do this to use less space, but I'm happy I got the answer, and thanks for following along. I will see you in the next video.